Alright, so in this video, I'm gonna be talking about another approach for biomedical event extraction using CNN and dependency parsing, because these syntactic structures gives us a lot of information that we can leverage to enhance and or outperform state-of-the-art event extraction models. So I'm going to be focusing on this paper on 2018. Event and relation extraction are a central task in biomedical text mining, where relation extraction concerns the detection of semantic connections between pairs of entities. Event extraction expands this concept with addition of these trigger words, multiple arguments, and nested events. So each of them could be another event. So they developed a CNN that can be used for both event and relation extraction. And they use a linear representation of input text where information is encoded with various vector space embeddings. So we encode the parse graph into this linear space using dependency path embeddings. We develop an evaluator method on a large number of event and relation corpora. For example, in BioNLP, you can use these data sets. So this TES system that is suggested works as a pipeline method that models relation and event extraction as 4 consecutive classification tasks. The first stage is entity detection, where each word token. The second stage is edge detection. And so, for example, in the entity detection stage, predicts a maximum of 1 entity per word token. So you see how we do convolutional neural networks for entity detection. And we use part of speech tagging entities. The distance is very important because it follows the approach in 2014 where relative distances to tokens of interest are mapped to their own vectors. Then relative position features are used to mark whether tokens are located before or after or in the middle of the classified structure, or if they form a part of it as entities, event triggers, or arguments. The next one is path embeddings, which describe the shortest undirected path from a token of interest to another token in the sentence. So we have entities, and then we get edges, then we get unmerging, then modifiers in the dependency parsers. And for shortest path embeddings, it follows the approach of the n-gram features. So it consists of tokens and dependencies connecting two entities of a candidate relation. For example, if the shortest path would consist of 3 tokens and 2 dependencies connecting them, then the shortened path could be written like this. And these are the corpuses. We use Genia 9, Genia 12, 2011, and these are the corpuses. You see the F1 score is relatively still low, still 71, and in Genia is 58. And you see that they have used CNN convolutional neural networks. They compare with the precision and recall and F1 score.